I hope you have installed Apache Spark along with the PySpark IDE on your PC. But before jumping on to the syntaxes and start coding your PySpark application, there are some basic concepts that you should really know. So that's we are going to cover, and also we will kick off our first Spark application. So I hope you are excited. So let's get started. Okay, so before jumping into learning syntax and start coding our Spark application, you have to understand some basic concept of every Spark application. This is very important because you should know what is happening under the hood with our Spark code. So you have to be familiar with some of the key concepts of Spark application which are given here. The first one is itself application, then we have the Spark session, then we have the job, stage and task. So let's discuss them in detail one by one. So by the name you will get an idea that application is nothing but a user program which is built on the Spark using its APIs. So there are different APIs which we have discussed in the previous lectures, and it consists of a driver program and the executor on the cluster. Then here comes the Spark session, which is a point of entry of every Spark application, and it allows programming Spark with their different APIs. And in your Spark shell, the Spark driver instantiates a Spark session for you. But during a Spark application, you have to create your own Spark session object ourselves. So as you've seen that when you kick off your Spark shell, the Spark session is already created for you. But when you write your code, you have to first create your Spark session and give the configurations to it. Then comes the job. So job is nothing but a parallel computation which is consisting of a multiple tasks which gets distributed in response to the Spark action. So what are action, what are transformation, that comes the next topic. And we have the task itself. So task is nothing but a single unit of work that will be sent to the Spark executor. So let's dig in further into these topics to understand how it works actually. So first we will learn about Spark application and the Spark session. So as we have discussed in our Spark introduction lecture, that at the very core of every Spark application is nothing but a driver program which will create a Spark session object. So we have already discussed it. We have like the Spark application, and in Spark application here we have the Spark driver, the driver which is again instantiate the Spark session. So here comes our Spark session. So this we already have discussed in our previous lectures. So when you are working with Spark shell, the driver is part of that shell, and the Spark session object is created for you, which we have seen in our installation lecture. So because you launched the Spark shell locally on your laptop, all the operations ran locally in a single JVM. But you can just as easily launch a Spark shell to analyze data in parallel on a cluster using the local mode. So once you instantiate a Spark session, you can submit your job in the various executors. So here we have the executors which works on every worker node in your cluster. And this is how your job will get submitted on each executor by your Spark driver. And this orchestration is done by the cluster manager, which you have discussed in our Spark architecture lecture. So now let's discuss about our next component, which is Spark jobs. So during you interact with the Spark shell, the driver converts your Spark application into one or more Spark jobs. So this will be our Spark driver, and your driver will convert our Spark application into different jobs. So here is our job 1. Then we can have multiple jobs depending upon the operations which you are doing in our Spark application. And our Spark driver then transform each job into a direct acyclic graph. So this direct acyclic graph, we can also call it as a Spark execution plan. So where each node within our DAC could be a single or multiple Spark stages. So this is our Spark driver which can split your Spark application into multiple jobs and submit it on our worker nodes. And the next one will be the stage. So stages are nothing but the part of our DAC nodes, and these stages are created based on what operation can be performed serially or the parallelly. So each job can have the stage. So here comes our stage. And not all operations can happen in single stage. They can be divided into multiple stages, and these stages can have the multiple tasks. That will be our next component. So tasks are nothing but can comprise of many tasks, which is nothing but a unit of execution, and which is then distributed across each Spark executor. So after stages, we can have the multiple tasks assigned to it. So here are our different tasks, and all stages can have this task. So this each task are maps to a single core and works on a single partition of the data. So for example, an executor with 16 cores can have the 16 or more tasks working on 16 or more partitions in parallel, making the execution of this task very parallel. So this was all about Spark application, the driver, then we have the jobs, and every job can have the stage, and every stage can have the multiple tasks. This is how your job is submitted to the Spark cluster and execute and do all sort of operation in parallel, and it takes the advantage of the DAG, which provides the optimum way to do all the computation and process your data. So now comes the next part, which is very important in Spark, which makes Spark very popular, which is lazy evaluation. Now let's talk about that. So the Spark operations on a distributed data can be classified into two types. The first one will be the transformation and the second one will be the action. So transformations, as the name suggests, it transforms one data frame to the other data frame without changing your original data, which gives it a property of immutability. So it cannot be mutable. So if we put it in a different way, an operation such as the select or filter will not change the original data frame. Instead, it will return the transform results into a new data frame. So data frame you can nothing but call as a table in a relational databases. So it has the rows and columns just like a SQL table, and you can do all sorts of transformation as well as you can apply some SQL queries by using the Spark SQL API. So all these transformations are evaluated lazily. So lazily means that the results are not computed immediately. So if you just apply any filter or select any specific column or join two data frames, it will not do anything unless you call an action, but they can be recorded or remembered as a lineage. So this recorded lineage will allow the Spark at later time in its execution plan, and it is very helpful for efficient execution. So this lazy evaluation is nothing but a Spark strategy for delaying the execution until the action is invoked. So actions are nothing but the count or collect or select, take, whatever it is. So if we just do all sorts of transformation in your data frame and you have the final data frame, which is nothing but a expected data frame you need as your output. And if you don't call any action, it will not do anything. That's called a lazy evaluation. It will just rearrange your lineage immediately and already calculate the more optimum way to compute your data. And once you call that action, it will convert it as a direct acyclic graph and submit it on your cluster and give the result in a more efficient way as compared to Hadoop. So this is the reason why Spark is way more faster than Hadoop, because Hadoop is like it splits your operation in the mapper and reducer phase, and it's like a linear method. It doesn't take the benefit of DAG, provide you the optimum way for processing your data. So this lazy evaluation strategy will allow Spark for optimizing our queries, and it does that by chaining the transformation, lineage, and the data immutability, which provides the fault tolerance. So these are some list of transformation and actions which are given here. So there are different transformation like order by to sort out your data, group by which is nothing but aggregate function, then you have the filter to filter out your data, then select to select some specific columns or records, and the join to join two data frames on a specific key. And here comes the action, which are nothing but show to display your data, then you have the take, then you have the count, collect, and save. So these all sorts of action are called after you've done all the transformation to your data frame. So now our next topic is the type of the transformation. So transformation are also classified into two types, like the narrow transformation and the wide transformation. So any transformation where there is a single output partition can be computed from a single input partition is called as a narrow transformation. So for example, like the filter transformation as well as the contains transformation will represent the narrow transformation, because they can operate on a single partition and produces the result output partition without any exchange of the data. So it doesn't need any data from other partition and all the shuffling, which can be a little bit time consuming. But there are some transformation like the group by or the order by transformation will instruct Spark for performing a wide transformation. So where the data from other partition is read in and combined and returned to the disk. So for example, if you are counting the word apple from the millions of words, each partition will have the different count of the apple word. So if we give like a group by operation on that, then it will force to shuffle off the data from each of the partitions across your cluster. And after that, if you apply the order by, which requires the output from other partitions to compute the final aggregation of your data. So that is why the wide transformation which shuffles out the data like the order by, group by can be a very costly operations. And if you're dealing with big data, you have to be very careful while applying this transformation because there can be very resource consuming and it may impact the performance of your Spark application. So just only remember few things. You have the narrow transformation like the select, filter and a wide transformation where you are shuffling the data, which is kind of expensive task and it is caused by group by and order by clause. So this was all about what are transformation, what are actions and what is lazy evaluation and how it helps Spark process your data in a more efficient way. So now our last topic before we jump on to our first Spark application is the Spark UI. So Spark UI is also very important topic and we have already seen Spark UI in our installation video. So Spark includes this GUI, which is nothing but a graphical user interface which you can use for inspecting and monitor your Spark application. And you can do that so in their various stages as given in this figure. You can see all the jobs, the stages and the tasks, and depending on how your Spark is deployed, the driver launches the web UI. And by default it runs on the port 4040 and you can see all the metrics like given here. So it can give you the list of scheduler tasks, stages and the task assigned to them. It also gives you the summary of the RDD size and the memory consumption, and it gives us the information about like environment as well as the running executors. And if you are using Spark SQL queries, it will display that as well. So it provides a lot of information and it gives you the holistic view of your application, and you can easily monitor the submitted jobs which are executed or any running jobs as well as the failed jobs, and also how they are performing on your cluster. So enough talking, let's jump on to our first standalone Spark application which we are going to execute using Jupyter Notebook. So let's get started. Okay, so let's get started with our first Spark application, and here we will actually learn about what a transformation and what are the actions and how it does the lazy evaluation. So as you are already aware that for every Spark application, Spark session is the first step. So you have to import the packages. So for PySpark script, you have to import the Spark session from the PySpark.sql, and for this type we have also imported the struct type, field, integer type and string type. So this is from the PySpark.sql.types. This is because we have defined a custom schema for our data frame which we are going to create on a CSV file. So once you import all the packages, you have to create a Spark session. So to create a Spark session, you have to use the builder method and you can provide a certain name for your application. So here we have given the first step, and the get or create function will get either the already created Spark session or it will create a new one for you. So we will run this step. Okay, so it has executed. Now we will create our Spark session. So we'll execute this one. So yeah, it is running now. It will take some time. Yeah, so the Spark session is also created, and here we have defined our schema for our CSV file. So our CSV file lies in the path of this directory. So here we have our Spark app, Jupyter Notebook, and we have the fake friends.csv on top of which we are creating a data frame. So this is nothing but a ID, the name of the person, the age and how many friends that particular person has. So this is the data, and it is not that much big. It is very small data set. This is just for your basic understanding. But in upcoming lectures, we are going to deal with huge amounts of data. Huge mean thousand and even lakhs of rows of a CSV files and the data coming from RDBMS. So that's a different topic. So for now, just again go to our code. Yeah, we will run this step to define our schema, and the next step would be to create a data frame on a CSV file. So here we have used the spark.read method, and here we have given the format as CSV as our file was comma separated, and we have given the path. So since this file already present in the same directory as of our Spark notebook, then we have given the name of that CSV file, and we have passed the schema as well. So we have built a custom schema for it to define the user ID, name, age, and the friends. So this is if your CSV file doesn't have any header, then you can give the custom schema for your data frame. And we have used the load function to load the CSV file into our data frame. And next step would be our transformations. So as I already told you that the select method as well as the where one, which is nothing but filters out the data. Then we have the with column to create a new column or transform the existing column in your data frame. So here we have given the select and we have selected the columns from our data frame. Then we have given the filter as age of that person should be less than 30. And we have added a new column insert timestamp, which will calculate the current timestamp when you are submitting your Spark application, and it will create an insert timestamp field in your data frame. And you are ordering it by the user ID. So order by is nothing but a wider transformation where your data will shuffle between the partitions of the data. So till now, these are all the transformations. So here comes our action, the first action. So let's load the data frame now. So we'll execute this step now. Okay. So we have created our data frame. Now we will perform all the transformation on it. And as you can see, it does it in a millisecond because it is a lazy operation. It really didn't selected or applied any filter on it. It just instantiate the path of your execution and created a DAG so that it will calculate the most optimum way to do all the computation. And here is the count, which is nothing but action on top of that data frame. So here, if we execute this, yeah. So this is how your Spark works under the hood. It does all the work when and only when the action is called on your data frame. So here we have taken the count, so it only has 112 records. Then let's see the data. So to just discuss about the Spark SQL, let's create a temporary view on top of your data frame. So we have given the output.create or replace temporary view, and our view name is peoples, and we can submit SQL queries on top of this peoples view. So all you have to do is you have to give the spark.sql, and in bracket you are directly submit ANSI SQL standard query on top of your data frame. And here again we have the show action. So this does all the computation. So let's create a view. That's it. And if we run this, yeah. So here comes your result. So these are all the persons which has the age of less than 30. Along with the number of friends and the insert timestamp column present here. So we are recording this video on 11th of February 2023, and as you can see the timestamp as well. So it will calculate the timestamp of when you submit your Spark application on a cluster and add it as a column in your data frame. So this is very basic, and this was just for your basic understanding of how Spark transforms the data and runs them as a different stages and tasks on your cluster, and what are the lazy transformation in Spark and how it benefits it to do the efficient processing of your data. So I hope you understood it very well. So if you have any difficulties, please let me know in the comments and I'll get back to you as soon as possible. If you like this video, please subscribe to our channel and also ring the notification bell to get the latest updates. And don't forget to follow us on our social media, which I have linked in the description below. Thanks for watching.